Hello, everyone. Welcome to the session. Yes, and this is one more session which we discuss or focus again on the topics of Snowflake, stream and tasks. And streams and tasks, they work with Snowpipe. We were talking about another example of Snowpipe. Okay. Before that, let us briefly talk about these topics of Snowflake. I'll just go to my mind map. Yeah, we have been actually talking about Snowflake for a few sessions now. We know what Snowflake is. Snowflake started as a data warehouse platform. Now they have a platform for analytics, big data, of course, big data processing, ML, AI. So all these kind of processing on data, analysis on data, you can do on Snowflake. So what is the USP of Snowflake is they are bringing up you a data warehouse solution where you can store your data anywhere you want, like AWS, Azure, GCP, object storages. See, AWS has S3 bucket, Azure has Blob, GCP has GCS. These are object storages, meaning they can store any kind of data, structured, unstructured, semi-structured, any kind of data that can be stored in these storage solutions. Now that is a separate entity. Now Snowflake is telling that you store your data there and you can build your data warehouse here on Snowflake. Not only that, you can also process your data. That part we will manage. Snowflake will manage the compute. Sorry, just give me. Yeah, sorry. Okay. Coming back to the discussion, Snowflake offers a compute platform. Storage is managed as a separate entity. It can be from AWS, Azure, GCP. That's how Snowflake started. And here the question is, do these clouds, AWS, Azure, GCP, don't they offer data warehouse? Yes, they also offer data warehouse solutions. But initially what happened is, this data warehouses offered by these clouds like AWS, Azure, they are like almost an on-premises database. The look and feel of them, the maintenance of them, they'll reside in the network. You have to manage the network related permissions, firewalls, policies of the network. And if you want to share the data warehouse to read and write with any external entities, you have to take care of all these things. Even though infrastructure is managed for the data warehouses by these clouds, AWS, Azure, and these clouds. So the downside is still it's not like a ready to use kind of a data warehouse. It's ready to use in the sense you don't get those ease of using the data warehouse. So let me give an example. Let us take an example of AWS Redshift. AWS initially they have the Redshift cluster, and if you want to make use of a data warehouse using this Redshift cluster, first you have to create missions, virtual missions. You have to manage your virtual missions. Of course, AWS provides support for auto scaling and all, but still you have to manage your Redshift cluster and the network around it and the policies, permissions, all these things you have to manage at network level and also scaling up. It is very similar to on-premises data warehouse, not completely. AWS manage the infrastructure, they will do that heavy lifting for you, but still you will feel that there is a lot more configuration is needed to make use of Redshift cluster, which hosts data warehouse solution. This is like, say, you're having an independent house, you have to manage everything. Of course, you have a support, like you, if you, I mean, water facility or electricity facility, all are provided for the house, for your independent house. But still, from your side, a bit of maintenance is required because it's a standalone house for you and you are the owner of the house. You have to manage if water is not coming, some short circuit happened, some trip happened in the house. You have to fix it or you have to look into it how to fix it. Bring guys and you have to fix it. This is Redshift cluster, which AWS provided initially as a data warehouse solution. And Snowflake, what they are saying, we will manage all these things for you. You can have your data on S3 bucket of AWS or blob storage of Azure or GCP containers, sorry, not containers, cloud storage, GCS, Google Cloud Storage, GCS we say. So anywhere, any of these three, you save your data. When you want to bring that data as a data warehouse, we will help you. If you want to do pre-processing on that data, we will help you. We will provide that compute for you. This is something like you are staying in an apartment in a gated community. Whereas AWS Redshift cluster is something like you are staying in an independent house of your own. You have to manage all the things in the sense you need not manage the electricity grid for your house, but still if some power cut is there, you have to figure out what happened and you have to fix it either by on your own or you'll bring someone who will do that. But Snowflake is not like that. It's like staying in an gated community apartment. Maintenance, all the issues like this, everything will be managed by the community itself. So that is the difference. And now the clouds like AWS launched Redshift serverless, where they will take uh, part in managing all the things end to end. And also in Azure, we have Synapse Analytics, same like end to end functionalities they will manage. And in GCP, they have BigQuery, which are almost equivalent to Snowflake. Meanwhile, they in the timeline, these clouds come up with those solutions. Snowflake has also become popular, and a lot of people has adopted Snowflake. So that is like brief intro to Snowflake. Snowflake has a lot of features for handling structured data, unstructured data, and you can use SQL, Python languages to process your data on Snowflake, even PySpark for big data. You can use all these languages on Snowflake once you bring your data into the Snowflake. Now, the bringing part of data into the Snowflake. Snowflake provides two things called stage and database. Databases, we all know, is nothing but organizing your data into rows and columns. That you can do. The data you have in S3, Azure, or GCP, you can bring into your databases. You want to do some processing on that data. You want to calculate averages, aggregates, you want to summarize your data, or you want to clean your data after coming to the Snowflake. So you can do that by using a temporary storage solution. No, you don't want to directly write data into the database. First, you want to do some processing on your data or cleaning on the data, and then you want to write it into the database. For such a kind of scenarios, Snowflake offers something called a stage. Stage is like a temporary place where you can save your data as it is. If you bring CSV or JSON or any other kind of data, structured, semi-structured, yes, you can bring into the stage as it is. Flat files or real-time data, anything you can put as it is into the stage. You can interact with that data. You can check the data quality, you can check the processing, you can apply the processing. Once you feel that your data is good, curated, you can put it in the database. Or if you want to directly write into the database and then you want to check all this, that also you can do. It's up to you, up to the data pipeline and the kind of data you are getting. And these are the two areas Snowflake offers, right? So the databases together is nothing but the data warehousing part of Snowflake. Data warehouse is nothing but you will be having all the data in one place. It is like a database actually. All the data will be available in tables. What makes difference in the data warehouses? It will be huge. It is a warehouse of your data. You will put all the data in one place. You will arrange them and you will make use of them. Suppose a business is having 10 years of data, all the 10 years of data will be in the data warehouse of different segments. Okay, now we will talk about three things in Snowflake, that is Snowpipe, streams, and tasks. So I already discussed about this in one of the last session. We will take another example. We will discuss more things, I mean, in more detail about the Snowpipe, streams, and tasks. Okay, I'll go to my Snowflake account and it is already there. I have logged in. And this feature, Snowpipe, what it will do, it will continuously monitor for the changes in the data. That is Snowpipe for you. And this Snowpipe works with external stages, not with internal. What is stage? Stage is a platform which Snowflake refers. It is an intermediary storage. That doesn't mean that data you have to delete quickly. You can keep your data permanently also. But usually people use it as an intermediary platform to interact with data. So once the data is processed, they'll save in the database, which will be the part of data warehouse. And suppose this storage is from AWS S3 or Azure Blob or GCP, GCS storages, we call them as external stage. And Snowpipe monitors continuously external stages. It will not work with internal stage. Internal stage of Snowflake, where you can use internally to interact with your data. But Snowpipe, which has to actually monitor for the changes in the data, unfortunately will not work on internal stage. It will work on external stages. And that is the thing actually needed. but it would have been good if they have provided it for internal stages also. But right now, Snowpipe, which is a service that continuously monitors for changes in the data, works on external stages only. Okay, suppose you want to use any external stage like AWS S3 or Azure Blob or GCP's GCS. First, you have to create something called integration. Because they were external, you have to tell whereabouts. Which storage, if it is S3, which bucket. Before giving the details of the bucket, first of all, which AWS account? What is the bucket name? And what kind of data will be coming? That anyway, we will, while creating tables, we will define. Bucket details, AWS account details, and if there are any folders within the storage, all these details you'll tell to the integration. And also, depending upon that cloud, secure connection. For example, AWS uses policies, roles. That roles has to be used to establish a connection between the external stage S3. Azure uses something called as shared access policies and also RBAC. So using those, you have to integrate with Azure's blob. Likewise, GCP also has an IAM like we have in AWS, but it will be slightly different. Using one of the security mechanism of those clouds, we will create a connection, secure connection. So all these details will be the part of integration. Yes, we are going to integrate with these external storages. So it's called as integration. So first we need to set up the integration and then Snowpipe, which monitors for the changes within that stage, external stage, S3 in our case. Okay, sorry, here. Here I already have my S3 and also Snowflake. I have logged into both the accounts and I'll duplicate this tab and here I'll go to my S3 console and this bucket I have created. I have named this bucket as Snowflake Integration 2025. This is the bucket and this is the Snowflake account. Now, let us go and talk about these details. A secure connection should be established. Sorry, yes. Yes, sorry for that. Secure connection. How it is, how it will happen is, we need to create something called as role in AWS. This role tells that, hey, you are going to share your service S3 bucket with some other external entity. Trust it and also allow it. Two things are there. Trust it and allow it. Trust means you have to create a JSON document called trust relationship. And for permission to allow it, it has to do some action. What action? It has to monitor S3 bucket. It has to take data from S3 bucket. So those permissions, two things we have to give in AWS. In AWS, we have to set up a role. How we are going to tell to trust and grant permission by creating a role. Now coming to our Snowflake part, we should create integration. And you can see here, already I have created a trust relationship. This thing we discussed in our last class also. You can just go to roles and create a role And you can say custom trust policy. And here you can write your trust policy. Suppose if you want to allow other AWS accounts into your AWS account, you want to allow Snowflake, you have to create a custom trust policy. In short, if you want to allow any external entities which are not known to AWS, you have to create this trust policy. After creating the trust policy, it will ask you to assign permissions. And I have created this role already. Just close this. Sorry. Yeah, continue. Snowflake S3 access role. This one, trust relationship is like this. What are we saying here? Allow this principal is allowed to connect with this external ID. So that's what we are saying. Where can we get this? After creating integration in the Snowflake. I'll just copy paste the things which I have done earlier. First thing is we have to create the database. If database is already there, we will use the database. Okay. First, we will create the database. Create or replace database DemoDB. Run it. And also in the DemoDB, we are creating a folder kind of a structure called public schema. We call it schema, which you can assume it is equivalent to folder kind of a structure. So it's a schema and we are calling it as public. In most of the databases, by default, schema will be public. Still, we are using the same name. If it is already there, it will be replaced. If it is not there, it will create a one schema with that name. And we are saying, hey, Snowflake, use this database and schema for the upcoming operations. Run it, okay? Then we are going to tell what kind of data is going to come into that database. It is JSON data. Create or replace file format. So file format is going to be JSON, or if it is CSV, you'll mention it as a CSV. Next thing. The main thing, the key part, integration. Sorry, here it is. Before integration, yeah. Creating the stage. This part is a crucial one. Okay, this one. Create or replace stage. See, I told you Snowpipe works with external stage. In our case, external stage is S3 bucket. And to connect with S3 bucket, we have to create integration. All the things we are doing in these few lines. We are saying, hey, create or replace a stage. We know that stage is a temporary storage in Snowflake. It can save data as it is. And we are calling it as order stage. And what is the base for this stage? Where we wish to create this? Not in Snowflake. Using S3 as a base, we want to create the order storage. So I am giving the URL of the S3 bucket. And that too, my stage is based out of orders data folder in the S3 bucket. See, this is my S3 bucket, and I have given the URI of it, not URL, URI of it. And you see the orders data folder. It has one data, which I'll delete it. Delete. Delete it. Now you see this folder is empty. This orders data folder. And this location, orders data folder location, we are providing here the URL. And saying this integration is called as Snowflake S3 integration. And the file format is JSON format. This is a crucial part. Why this is crucial part is this Snowflake integration details we have given in IAM. We have given these AWS and the external ID. These two are related to Snowflake, this integration. So just give me a minute. Okay. Sorry for keeping you waiting. I'll just say describe integration. And the integration name is Snowflake S3 integration. Just copy with this. Run this. Okay. So these are the key things. Once you create this integration, you'll get two things. Storage AWS IAM user ARN. Here you see this one. And the external ID. Storage AWS external ID, this one. These two, if you see, these are part of role. See, this one, this 4 zeros hyphen S, you can just see the same thing here. And the storage AWS external ID, and the same thing as this. So here initially what you have to do, you have to create a trust relationship first. Without knowing these details, you have to create the trust relationship. So it is better to make use of some random IAM in this structure. Instead of this ID, you will make use of your own account ID, something like that. Some fake ARN you have to use in this structure initially. And also here you will use some random encrypted thing, and you will create trust relationship first. So that AWS will know, yeah, we are going to trust some external entity. Once this is done, you will come here and you will create this integration. So you are actually giving the whereabouts of AWS bucket here. You'll run it. And when you run it, you will get a different role, different AWS role, different IAM user ARN, different AWS external ID that you have to make use of here. And to make this all happen, one more thing you have to do in advance is while setting up Snowflake, you have to give your AWS account details. So this is working now. And you can see I was able to get these details and I was able to create the integration and describe the integration. Now the integration part is done. Now we will create the snow pipe. Snow pipe. Before that, we'll create some tables and then snow pipe. Sorry, I have this in a different account. I'm getting confused. I'm going to my account rather constantly. I'll just close this. We are creating a table, create or replace, and we are saying orders raw. I'll just run it. Okay, variant is a data type, like we have int, we have string, we have boolean, we have date time. All these are data types we have. Variant is a data type saying that whatever data comes, you put all the data into one column. We call that column as variant. Whenever you define a column name as variant, that means all the data coming, especially it works well for JSON data. All the JSON data that is coming, put in that variant column. Don't try to look into the attributes, create columns. It will not try to do all such things. Just one variant column. That column name is raw data. Since the data type is variant, the name itself says variant, like a COVID variant. Whatever variations happens to the data, it will just put all the data, one time data, one telemetry data into one column. So that is the meaning of this. It's a data type, special data type in Snowflake. We'll run this. Because it is semi-structured data, I don't know exact columns that are coming. So it's better to create a thing like this, table like this with variant column. Later we can categorize according to the attributes coming, we can define our columns. Okay, this is a table. Now next thing is we will create snow pipe. Sorry, snow pipe. Create or replace this one, snow pipe. We are naming the pipe as orders pipe. See here we are creating a pipe. What it will do? So like a table means rows and columns will be there. A pipe, what it will do, whatever stage you give, it will be constantly observing that stage. In our case, that stage is S3 bucket, see order stage. And we are saying snow pipe, create snow pipe on it. That means continuously monitor it for the changes. And the file format is JSON format. Okay, whenever a new data comes, what has to be done? Now, Snowpipe will be monitoring the data. It will be like it will identify the new data. What that data has to be done? It has to be written to the variant raw data, the column, sorry, the table raw data with variant column. There we want to write this data as it is. Okay. For that, we have to create something called stream. Okay. What stream will do? The changes that has been detected by the snow pipe will be ingested into the table. Here, raw data we have created. Sometimes if you want to start over your snow pipe, then you can use this. Alter pipe orders pipe refresh. Okay, let us run up to this part. Already we created the integration, we created the raw data also. Up to here we have done. And now creating the snow pipe. Run it. Demo public order stage does not exist or authorized. Let us run it once again. And the snow pipe. Yeah, now it was successfully created. And we will also run this, just refresh, just only it was created. Refresh is not required, but just we will run it, refresh it, and create the stream. Why? As soon as data comes, SnowPipe detects, stream has to write into the raw table. So let us also create this. Now I'll go to my S3 bucket. I'll upload data. You can also write a small code to continuously ingest data, but here to keep things simple, I'm uploading the data. Last class, we have seen IoT data, which will continuously come into the S3 bucket. Here we will keep things simple. I'll just upload files directly, add files. Downloads. See, I have this order batch one, which is a JSON data. I'll just upload it. Upload. As soon as I upload this, Snowflake has to detect the change and it has to stream into this one, raw data table. Okay, let us say select everything from raw data. Can we let us copy this? It's orders raw, sorry, not raw data. Column name is raw data, table name is orders raw. Query produce no results. What might happen here? Let us refresh, alter pipe, orders pipe, refresh. Run it. Okay, now it is saying that order batch one dot JSON sent after refresh. Let us check this. Okay, let us run this again, streaming. Run it. Okay, now we got. See, this is the data which I have uploaded into the S3 bucket. It has around 10 entries of JSON data, like customer name, order ID, order timestamp, and the product. These are the attributes or key value pairs. If it is a CSV file, column names. It was like this. Now, I'll just create a table. Now, I don't know. Initially, I don't know what attributes are going to come. I created a raw table. Now I understood the attributes and the attributes that the data has. So it is having column names like this: customer name, order ID, order timestamp, and product. So here I'll create a table and arrange the data in table. And after data comes into the stream, the operations which you do in the table or in the data coming from the stream are called as tasks. First, we will create a table because we want to arrange the raw data, table, which is having only one column, and that column is having all the attributes in that one column. We want to convert that raw table, data in the raw table, into a proper table. We don't want a variant table, a table like in a SQL database. Create or replace table, name order processed, and you see with the things that we have seen in the raw data, those attributes: order ID, customer name, order amount, product, order timestamp. One more attribute, processed at timestamp, we are adding because it is being processed. It is being picked up by the pipe and streamed into the raw table, orders raw table. So the process time also we are adding. Run it. Now Snowpipe is done. Now you know what is a Snowpipe. Snowpipe is a feature in the Snowflake that continuously observes the external stages like S3, blob storage, and GCS. Whenever there is a new data into those storages, it identifies it and also picks up that data. We created a Snowpipe here. So this is going to be the stage which Snowpipe is going to continuously monitor. Order stage, which is nothing but the S3 bucket. And we created a pipe. And we want to stream that data. That means nothing but writing the data. But why we are calling it streaming? Because pipe detects only the latest changes. And stream will stream only the latest changes. So we are calling it a stream. It streams means nothing. It picks up data that was collected by the pipe and writes into the table whatever you mention here. And we have created the table in advance with one single column called with a variant data type. And we are writing into it. That is streaming. Now, if you want to do any pre-processing on this data, if you want to segment into proper table, or if you want to do any other operations like counting, averaging, aggregating, cleaning your data, those things you can do through tasks. Now we will write a task. See, all this up to here is a task. What it says? Create or replace table, sorry, not this one. Create or replace task, process orders task, and warehouse is compute warehouse. Now here we are mentioning the data warehouse. You have to check the data warehouses in your Snowflake. We are using compute warehouse. What are we saying is every 1 minute, just look into the order stream and write all the data into a table called this one, orders processed. And this orders processed, we are creating a schema, order ID, customer name, order amount, product, order timestamp. But you see this processed at timestamp. This is Snowflake processing time. All these attributes are part of data, but this particular attribute or column name is the processing time of Snowflake. So when that data was processed, that time also we are attaching. So insert into orders processed, from where first we are collecting from order stream. Collect from there and insert into orders processed. Orders processed is already having these columns. So the whatever JSON data is there, we are picking up the attributes or the keys of that JSON data, and we are writing into these columns. And that is a task. And we have scheduled the task for every 1 minute. Okay, let us run this. Task has been created. I'll just refresh the pipe, refresh the pipe. And then let us select everything from processed. Yeah, this one, orders processed. Processed table. Run it. No results. Maybe we should also run the stream once again. Refresh, run or refresh the stream. Where is the stream? Create or replace order stream. Run it. So you can create a schedule for every 1 minute like that to refresh the stream. Now, once all these are done, I'll check this once again. Still no query results. I'm running this once again. Now select it. We will do one thing. We will select the stream also. We will check the stream. Order stream. Run it. Refresh the pipe. It takes some time because it has to connect with AWS. And orders pipe is anyway getting the data. Order stream. Run it and check the stream once. Just give me a minute, I'm checking. You will get something like this case. It takes some time. Initially, it took some time, 5 minutes or so. It will take some time for initially. After that, as data coming in, it will immediately diagnose. Finally, you will get something like this. You see, this is the query result of final one, orders processed. And say query ID. So finally, our objective is we are arranging the unstructured data or semi-structured data into structured format. And that too in a continuous flow. As soon as data comes through Snowpipe, stream, and task, we are doing that. Every 1 minute, if the new data comes into the S3 bucket, it will Snowpipe will collect it, stream will write into the raw table. Task for every 1 minute get from the raw data table and writes into this table. So just you have to be constantly refreshing the things. That's it. You have to do two things. One is you have to refresh your orders pipe and then alter task. You have to resume the task. So after a few minutes wait time, you'll get this result. Okay, that is about the snow pipes continuous, what we say, ingestion features that supports continuous ingestion of data. Snowpipe, stream, and tasks. We can also automate this pipeline. Right now, this pipeline is not automated. So using few other features, we can automate it. That we will talk in our next sessions. Sorry. Yeah. Thank you.